All right, folks. Thank you for joining us for the first seminar in our 2025 California Fire Science Seminar Series. We're going to go ahead and get started. My name is Katanya, and I'll be your host for today. I am a statewide coordinator for the California Fire Science Consortium, part of the JFSP Fire Science Exchange Network. The California Fire Science Seminar Series is organized and supported by the California Fire Science Consortium, the Fire Research Group, the University of California, Berkeley, and the University of California, Merced. I also want to acknowledge our student committee, who were integral to the success of this seminar series, which included 18 students and postdocs from across the nation who helped select speakers and topics for this series. This webinar is being recorded and will be posted on the California Fire Science Consortium website and YouTube channel. Following today's presentation, there'll be a Q&A session, so please feel free to add any questions you have to the Q&A chat throughout the presentation. So it is my pleasure to introduce today's presenter, which is Professor Scott Stevens, who will be discussing the early impacts of fire suppression in Jeffrey pine mixed conifer forests in the Sierra San Pedro Ma, Mexico. Scott Stevens is a professor of wildland fire science at UC Berkeley and a leading expert in the field, specializing in the interactions between wildland fire and ecosystems. His research covers the role of prehistoric fires' interaction with ecosystems, how current wildland fires are affecting ecosystems, and how future fires and management will shape both people and ecosystems. He is also focused on improving fire and forest policy to address the challenges of the coming decades, both in the US and globally. Another key area of research is working with Indigenous partners to learn how to steward ecosystems into the future with climate change. In addition to his research, Professor Stevens has testified before the US House of Representatives, the White House, and state agencies, and recently served on the 2024 US Wildfire Commission. He is on the board of directors of the Climate Wildfire Institute and is one of the leaders of the Stewardship Project, which is a partnership of Indigenous people and Western science to improve federal fire policy. So with that, please join me in welcoming Professor Scott Stevens.
Thanks, Katanya. Very nice introduction. Hi, everybody. Seeing you in virtual land today. I get to talk to you about one of my favorite places in the whole world. So this is kind of a nice talk for me to give, the Sierra San Pedro Ma. I went down there first in June 1998. So I've been going back there ever since and have really just found an amazing place and a place that I continue to go back. We were back there last May and did some work as well. So I'm going to talk to you about certainly these early impacts of fire suppression. I'm also going to kind of set the talk up a little bit with some previous research that we've done in this site. So in case you've never been there, and you can go there, it's really easy. All you got to do is drive across the border of San Diego, go south, past Ensenada. Ensenada is about halfway. Take a left, go east, up to the Sierra San Pedro Ma National Park. The road is completely paved now. Used to be a nightmare, but now it's actually completely paved. You can drive a Toyota up that sucker. So you can go to this park if you want and camp. So it's about 40,000 acres. It's one of those sky islands like in Southern California where you have a lot of chaparral below. Go up higher, you get the conifer forest. I'll show you some pictures. It's got 3 plateaus. Southern plateau is the lowest, only Jeffrey pine down there. Middle plateau, and then actually the upper plateau, the one most to the north, is the one that's accessible easiest by the road, and that's where I've done most of my work. So it's about 2,700 meters or so. It's pretty high. The tallest mountain there is Picacho de Diablo, just over 3,000 meters. Jeffrey pine mixed conifer forest. When you're there, sometimes you're wondering, am I in place in California or maybe Lake Tahoe Basin, the transverse ranges, peninsular ranges, mountains, Southern California? There's a lot of places when I stand there, it feels like I'm somewhere else, okay? And the thing about this place is interesting is fire suppression really doesn't begin until the 60s, the late 60s. That's when they built the first road up there to build an astronomical observatory. It's the largest in Latin America. But indigenous burning actually is suppressed much earlier. And there's a paper there, Evid et al. 2007. I'll show you some evidence of that here now. So there's a martyr, the little red diamond. So you can see that's the peninsular range of mountains, goes all the way down the spine of Baja. through the international border, San Jacinto Mountains, things of that nature. So that's the location of the Sierra San Pedro Ma. And one of the first things we did down there was a fire history study, just like a lot of you worked on, where you're taking samples from snags, live trees, and you basically date them. We did a couple studies down there. One of them I'm going to show you here is 2 1 square kilometer areas, pretty big areas, where we collected a whole bunch of fire scars, one on granite soil. Another one is actually on quartz schist metamorphic. So the granite is diorite. So let's take a look what the fire history shows us. So this is the fire history from those 2 sites I just told you about. Site 1 is granite. Site 2 is the metamorphic. And maybe you know, but each horizontal line is actually one piece of wood. So each of these horizontal lines is one piece of wood. Each of these little black vertical tick marks is a dated fire scar. So dated fire scar. So one thing you can see, certainly it looks a little different, right? It looks a little different right around 1795 or so. We see some samples where we have the same fire recorded over both areas, and they're about 6 kilometers apart. So you see synchrony in some of the dates, right? But you also see, especially in the earlier part of the record, you see some other fires that are much less synchronous. You don't see them all over majority of the samples. There are a few. You certainly see this fire here that actually synchronizes, but you also see an awful lot of smaller fires that actually just burn a few trees. And you see on the slide, 1794 is when the Sierra San Pedro Ma mission was actually created. We think predominantly this is actually a change in indigenous fire, far less indigenous fire on the right, and then lightning dominated on the left, both lightning dominated and also indigenous burning that occurred. There's also some climate signal in this that I won't go into today, but there is a climate change phenomena that happens around 1800. We think also is part of this, but by far we think this is mostly a change in indigenous burning as the indigenous people were collected and taken into the mission, similar to California. Here's what it looks like. Pretty open, isn't it? Yeah, it is open. Every time I go down there, I'll be honest with you, it gives me hope about what California forests that are frequent fire adapted could become, just in terms of its character. We'll talk more about that. So there you are, some Jeffrey pine, a few logs in the ground. You see the diorite. If you look at forest composition in an area we've been working for the longest time, set up a set of plots in 1998. From a basal area standpoint, it's about 2/3 Jeffrey pine, about a quarter white fir, 9% sugar pine, a little teeny bit of lodgepole, and the even smaller amount of quaking aspen. If you look at the number of trees per acre and also the basal area, you see we got about 60 trees per acre, but the variety 128 to 12, so 12 to 128 trees per acre, and the basal area average about 86 square meters per acre, 20 square meters per hectare. And then the range from the US side, again, about 25 square feet to 218 square feet. So I want you to keep thinking about for a moment that incredible variability. And this is an area that's not very large. I mean, we're talking about a few square kilometers on the same aspect, the same soil type, same slope. So we're not looking at a huge number of variations of those factors, but we're still seeing incredible variation in forest structure. Snag density. So if we look at snags at the site, and we've been measuring snags down there, around 1.7 snags around 2001. And then we had a drought down there, increased slightly to around 2.1 snags per acre. So relatively modest snag density. Here's a picture of a few. We actually dated all those snags, so we actually know when they all died. So we've done that as well. So we've gotten a sense of just how frequent these things are dying, and maybe some things that are correlated to them. There's this little group of 3 snags. How common are the average snag densities? So it's around 2 per acre, okay? So about 0 snags on about a quarter of our plots, less than the average density of 2 per acre on 2/3 of our plots, and you get a greater than about 4 snags per acre on about 14% of the plots. So the conclusion is the average snag density is rare. And this is something that actually keeps coming up in the martyr over and over again. You can calculate average characteristics of snag density, basal areas, tree density, fuel loads, and you find out if you go out and try to measure and actually measure plots, you find that the average characteristic is a very rare event. You find either much less, which is actually common, and then sometimes a little bit more. How about average fuel loads? Well, you go down there, surface fuel loads, that's a 110, 100-hour fuels, about 7 tons an acre, and less than average 75% or 73% of the plots, less than that average value, greater than 8 tons and about a quarter, greater than 16 tons and 8%. So we here from the fuel perspective, we find from our work down there that the average fuel load happens around 14% of the time. So this is one thing that really, after a number of years down there, really started to scream at us. The idea of managing for average characteristics at the stand level over and over again is something that I'm afraid we do a lot in California. Oh, we want 4 snags per acre. Oh, by the way, we want it on every acre. Oh, we want maybe, 100 square feet, 150 square feet per acre basal area. Oh, by the way, we want it everywhere. Turns out all these average characteristics in the Sierra San Pedro Ma are rare. So I think it's one of the reasons why it's so resilient. We'll talk more about that as well. We've done some 4-hectare stem maps in the picture on top. That's actually inside the 4-hectare stem map in the Martyr in the granite site. The middle picture is the 4-hectare stem map in the Martyr in the metamorphic site, quartz schist. And the lower one is actually a 4-hectare stem map we actually put on the Inyo National Forest on the east side. So we got some data here we can show you. So the top 2 panels is Tea Kettle, which is actually Malcolm Norris Research Forest. He's been working there many years. That's the upper right. Upper left is Lost Cannon Creek. That's the one from the Inyo that I told you about. And then the 2 on the bottom are the ones we've been talking about. The granite, Sierra San Pedro Martyr, lower left, and this Martyr metamorphic, lower right. If you look at these places and you start looking at things like individual trees, clumps of trees, sizes of trees, patchiness, from this paper from Danny Fry, you find out you get a lot more patchiness in both the Martyr sites and also far less large aggregates of trees. Not surprising, right? I mean, the 2 bottom ones the 2 top ones have had fire suppression for over 100 years and really a lot of infill. And the 2 in the bottom, fire suppression didn't begin until 1970. And I didn't tell you, but none of this area has been harvested at all. There's no harvest at all. You can go down to the Martyr and you can find a few places that have been harvested, but you got to hunt for them. It's very rare. But these places we're talking about today, there's been no harvest at all. So similar to some work like Eric Knapp and others have worked on from this 1920s plot he had on the Stanislaus National Forest, infill has happened, aggregation of larger clumps of trees, and really decreased heterogeneity spatially in California. In Mexico, it's still there today. What about a wildfire? So I know I'm getting close to this point where I'm going to show you the most recent data we have, but I really wanted to show you some of this other stuff. So remember 1999 to 2002 in Southern California? That was a major, major drought. Lake Arrowhead, that area down there had maybe close to 90, 100 million trees die just from bark beetles and drought with no fire at all. Same drought happened in the Sierra San Pedro Martyr. Same drought. It's bone dry. By the crow flies, areas of the San Jacinto Mountains to the Martyr, maybe 100 miles. You're talking about the same place, essentially. It's the same mountain range, peninsular mountains, okay? So you had all these trees, millions of trees die in the San Bernardino National Forest of Cleveland, also other forests in that part of the world. Down the Martyr, we had the same drought. And then in 2003, there was a small wildfire that actually got started and burned into the Martyr. So think about that for a minute. 4 years of the most extreme drought that you could ever imagine, followed by the next year, a wildfire. What would you expect in California? Well, you'd expect, unfortunately, a mess. You had very little survivorship just from the drought itself, let alone the fire. So I want to show you some data from this area of the wildfire we worked in. Here's a picture 10 months after that 2003 fire. Those are sugar pines there, right there in the front, you can see. In fact, that whole picture burned. The background, foreground, all that burned. And then here's the same picture of the sugar pines in 2019, that many years later. That one tree to the left, a Jeffrey pine, has died, but we see those 2 sugar pines continue inside that burned area. And if you look at some real data here and also some other aspects of this fire, here's a patch. We worked in a 16-hectare watershed, not a real big area, but this is hard to get to. There's no roads down to this country. You got to hike. So we found a small watershed and used it as our focus of mortality assessment. And here's a small slope inside that 16-hectare watershed that didn't burn at all. In fact, that's green leaf manzanita right there in front of us. So here's areas that basically completely missed by the fire, even after 4 years of drought, and then fall of fire. Well, at the end of the day, we found out that 80% of the trees inside the 16-hectare watershed survived. They survived the 4 years of extreme drought followed by a fire. Interestingly, 50% of the smallest trees died, not surprising. They have less resistance, right? But 50% of the largest died too. I think that probably was something to do with the stress applied by that drought. So 50% of the largest trees died as well. Fire is very patchy. We did some spatial statistics, pre-fire, after fire, and the fire maintained the spatial heterogeneity of the system, patchiness. It didn't simplify anything. It maintained it. And mortality of this site was incredibly low, even after a severe 4 year drought and also followed by fire. Resilient. The forests of the Sierra San Pedro Ma are the most resilient forest I've ever been in my life. So every time I go down there, I just see what that place is. I see essentially in our research and our colleagues have done so much work down here, go through drought, go through wildfire, bark beetles, whatever. I mean, the place basically keeps kicking. And it just tells me just how resilient these systems are when they're relatively intact. The martyr is not pristine. 200 years easy of livestock grazing. Fire suppression started in the 60s. It's starting to have an impact. I'm going to show you the data on that. So I would never call it pristine, but I think it's actually one of the few places in a Mediterranean climate with a frequent fire regime every 7-15 years or so that actually has this capacity to show us just how resilient these systems are. Julia Murphy did a great paper in 2021 looking at the relative stand density index down there. Some of you maybe have seen some of the work on relative stand density index, and it's a way that you can look at the competitive environment. And if you look at the martyr today, most of these stands are in the free of competition zone and a little bit in the partial competition zone. Those are the two zones on the bottom of the relative SDI curve, essentially with very low densities and very little competition. Just like our 1911 data from the Sierra Nevada that we've looked at over 4 or 5 places today. So you look at the martyr today, yeah, it's in a very low density, low competitive environment, relative stand density below 35%, a maximum, and a lot of it below 25%. Here's a little patch of high severity fire inside the 16-hectare watershed that we were able to observe. We found out that local shrub consumption was actually correlated to high severity patches. So it really was the shrubs that were many times vectoring fire to the overstory. And we found out in this 16-hectare watershed, about 5% of it burned at high severity with very, very small patches. This is kind of what it looks like today. We were back in this place last in 2019, and here's what the wildfire area looks like after the 4 year drought, fire, and then subsequently number of years, about 16 years later. This is kind of what it looks like today. Pretty amazing place. So wildfire severity patterns, colleague Iram, who actually is a professor at University of Northern Baja California, Hugh Safford worked on some remote sensing fire severity. So you see in the center of that slide, the average high severity patch size, 2.9 hectares, the median 0.63, and the largest 11 hectares. And this is not over a huge area of forest burn because they keep putting fires out down there, but it's over a couple thousand hectares of burn since 1984. So that's incredible. And the high severity percentage throughout that whole period is 3%. So there's some evidence of low severity fire actually happening, right? And we're talking about very small patches of high severity, overall 3%. Incredible, incredible. Here's some data of the last measurement that we've taken. This is 1998 to 2023, 25 years. So this is the fuel loads in our plots over that 25-year period. So here we've got information in metric tons per hectare, megagrams per hectare. Between 1998, the same plots, repeat plots, and we put that paper out. I think you saw the abstract of it. And what we see essentially is, interestingly, the 1 hour fuel loads significantly decreased. Why? I don't know. I just can't answer that very well. But the 1 hour fuel loads significantly decreased slightly. But the 10-hour, 100-hour, and 1,000-hour loads all increased. Fine woody debris, FWD down there, was 110s and hundreds. It increased. And the total fuel load goes from 25 megagrams per hectare to 75. A lot of that actually from larger fuels that have accumulated in that 25-year period. So we argue in the paper this is the beginning of fire suppression signal. It's not surprising to you, right? Take fire out for 30, 40 years, and you're starting to see accumulation of woody biomass. This is exactly what happened in California, right? So, showing Kotak, all these people start beginning to record this, write about it, and this is what's happening today in the March here. We're seeing increases in fuel loads driven by the exclusion of fire. Here's actual graph of some of the data more from the live side. So tree basal area has not increased at all. It's slightly increased, but it's not significant. Snags did increase from 1998 to 2023, snags. Seedlings, no significance. Tree density, interestingly, tree density did increase 2023. So we're seeing recruitment of trees into the lower size classes of kind of the tree form. And then what species is doing that? It turns out it's Jeffrey pine. You see the last graph there in the bottom. No changes in white fir, lodgepole, sugar pine. But we're seeing actual more recruitment of Jeffrey pine on this side into larger sizes. So again, I would just argue this is the beginning of a fire suppression signal. Some ways you'd wonder, why isn't white fir recruiting? This is something we're looking into. Actually, one of the PhD students, Lex Bernal in the lab, is looking into this and wondering if somehow the white fir is getting a competitive disadvantage as maybe climate warms down here. But at the end of the day, we're seeing, yeah, the beginning signals again of fire suppression, but the beginning, certainly not something that's majorly problematic, but still the beginning. So after 25 years, we're seeing essentially changes in this forest structure that in some ways are predictable. Increases in fine woody fuel, increases in coarse wood, starting to see slight increases in forest density. Interestingly, it's the Jeffrey pine that gets a little bit higher. And we've been talking to managers down there, along with Hugh Safford and others, for a number of years, trying to just talk to them about the idea, can you get fire back in this system? Can you get fire back? When the biggest issue down here is the observatory. The observatory is the largest in Latin America, and they tell me maybe the third most clear skies of any place in the world for astronomical observatory. So they've got a real issue with their issues of, they want clear skies, they want to be able to use their telescope and all that's fine. But I think they realize, especially in the last few years, they actually had a wildfire get within 5 miles of their observatory. It was started by a campfire that was left unattended. So that wildfire got within 5 miles and it really made them nervous. I was talking to them about this very data that we're looking at right now, just last summer when we were up there in May, beginning of talking to them about this. So can you get fire back in these systems? Talk about an easy place to prescribe burn. You can walk around this country. You can see hundreds of feet. You got dry creek beds, sometimes creek beds with water. You got rock outcrops. You got a few roads, not too many. But you could really begin a fire operation down here in earnest if you wanted to. And I think that the Mexican managers and others are considering that. And the frequency of fire is certainly down. And this is actually one thing that I didn't show you, but the seasonality of fire is early wood. So it has the seasonality of burning like New Mexico, Arizona. We think most fires in the historical record are June into early July, and very few in the fall, very, very few in the late wood. So this is a frequent fire regime, a little bit different in California in the seasonality, earlier in the season, June, July, not as much in the fall and the late summer like we have. So that's one difference between the Martyr and the forest of California. But I think you could begin in earnest a prescribed fire operation. We've talked to the folks at the observatory and other managers. What about a 2-week period where you could start to burn in earnest before the summer rain? They get a lot of summer rain down here, so you generally get very good convective storms starting maybe mid-July to late July into August. So maybe you could burn before that period. And you're not going to have too much smoldering. You're going to have some smoldering because you got those big logs in the ground now. They're going to smolder for a time. But the litter and life, small fuels would burn with flaming combustion quickly and very little smoke production. So I think you could certainly mitigate the site with prescribed fire and begin that in earnest. And I really hope the folks in Mexico could do that. So here's the last slide, and hopefully you got some questions for me. What about forest management in California frequent fire forest? Well, I would say from the martyr for sure, high spatial complexity is really a integral part of this. So, standards and guides, at least in the federal system, many standards and guides continue to be written for average characteristics over every acre. And it's getting better. I've seen some standards and guides that are getting more creative, differences on slope, differences maybe on aspect. But I think this is an area of the martyr that is why, one of the reasons why it's so resilient. Wildfire just can't get any head of steam down here. There's too many gaps. It's also low density, but you can't really get any gaps on the wildfire at all. So you can't get steam up and actually increase intensity and kill trees over a large area. It's also probably one of the reasons why things like, pathogens and insects are also modest. Jeffrey pine beetles down here, scolitis is down here, mountain pine beetles down here. We've trapped them all. But they basically kind of provide this background mortality, which again is probably much more conducive to what California forests were 300 years ago. So this idea of more variation in our desired conditions for our stands at the stand level and go up to the landscape scale is one thing the Sierra San Pedro Ma screams for us. And this idea of resilience, trying to get more resilience in our systems and just not focus on fuels. I know we're doing that too. The fuels thing is easier. Get rid of the surface fuels, moderate the ladder fuel. You've got a pretty low hazard forest. What about resilience? So how do you get resilience? I think the relative stand density index is one proxy that helps us understand resilience into the future. And the martyr needs to get fire back. We know exactly what's going to happen down there if they continue on the path they're on today. It's just going to change to something that's much more analogous to what we have here in California. Higher density, higher fuel, more stand replacing fire, and less resilience. Okay, this is the way it is. So I think there's still conversation about this. It hasn't happened yet. They're talking about it, but I have to say they've been talking about this for 30 years now almost. Okay, but they're getting maybe a little closer. I got to give huge shout out to my good friend Ernesto Franco. If it wasn't for Ernesto, I never would have worked down here. I met this guy in June 1998 up in Vallecitos Meadow in the Martyr with Pat Shea. Pat Shea was a former research entomologist for Service Pacific Southwest Station. Ernesto was such an incredible person. He worked for SESESE, the Federal Research Lab in Ensenada, and we created a research team together that persisted for decades. If it wasn't for this gentleman right here, I would never have worked in the martyr. That is one cool guy. He passed away probably about 3 years ago, 2.5 years ago, unfortunately. But I still think of him a great deal. What a colleague and what a neat person. I missed seeing him. He's a neat guy. Here are some other folks I need to acknowledge, including Ernesto and others: Carl Skinner, Brandon Collins, Danny Fry, Samantha Gill, Cal Poly. Huron, professor at University of Northern Baja, incredible. Mexican managers that have worked with us over the years, been very, very great people. They've been very nice all the time. It's been a great place to work. And again, every time I go down there, it gives me hope of what California forest could become and the ability to deal with things like fire, climate change, insects, all the other things that are coming at our forest. So it's been a really pleasure to work down there, and I've enjoyed it immensely, and hopefully we've learned a few things. From that, maybe I can stop sharing here, and folks, if there's any questions at all or comments, I'd be happy to hear them.
Thank you so much, Scott. Yeah, we do have quite a few questions coming into the chat. As a reminder, you can add any questions you have to the Q&A chat. So we have a couple of questions asking about grazing in the martyr. So when was it introduced, and do you know how heavily it was grazed?
Yeah, that's a great question. And that fire history diagram I showed you, right? And we showed the diagram how it changed abruptly about 1795, 1800. And we actually know that the Sierra San Pedro Martyr mission brought livestock in. Through a little luck and some help, we actually found the livestock records of the early mission. And they actually were in the middle plateau. I didn't tell you that, but they were in the middle plateau for a short time. Turned out to be too cold, so they went to the southern plateau about 8 years later. But the early livestock records are something on the order of maybe 800 head of livestock, including cattle, horses, and a few other things. So we really believe, since it was at least 20 kilometers away from, I think even 25, 30 kilometers away from where we are working, we think that that signal of change in fire regime in the late 1700s is not a livestock signal at all, because we were very curious about that. We've also done some work down there with Rand Ebbett, the fellow I mentioned before, on phytoliths. So trying to look at what evidence is there for maybe a perennial grass understory in the martyr versus what we don't really have that too much in California. We certainly see that in New Mexico, Arizona. He did a pretty extensive survey of soils and downcuts and things of that nature down in the martyr. He came to the conclusion that the phytolith density was very low in the forest for the last several hundred years, certainly high in the meadows. And unfortunately, the meadows are overgrazed. I'm not a grazing expert, but I've seen the meadows get overgrazed. Even though it's a national park, there's tension about the Hitos down there having access to resources, which they had for a long time. The park was built right over the Hitos, and not everyone was ever compensated. So grazing today still is, I would say, relatively unregulated and really harmful to the meadows. And I would probably even say probably even had some impact to the understory of the forest. But that's what we know about grazing.
Thank you. We have another question here. Is there a danger that Mexico has started to adopt a fire suppression
Mm.
culture similar to that of the US? And if so, are there strategies to revive the practices that led to a healthy martyr forest in the 60s?
No, very nice question. And there is a danger. I remember one year, and I don't remember years very well. One thing I got to say about the martyr that I really messed up on everybody, I did not keep a journal. Okay, so if you ever start a project like this, keep yourself a little journal, okay? Write down a few things every year because I didn't do that and I really regret it. All the people I brought down there over the years, all these things that I've witnessed down there, what a cool thing to have a journal. But I do know that when Schwarzenegger was our governor, there was a fire in the March here, started by a lightning strike in a very remote area. He sent CAL FIRE down there. So CAL FIRE engine showed up, and I was talking to some of those folks, and there was no access to this fire whatsoever. They got a bulldozer, tried to do some kind of line construction access, and it was just a total nightmare. It was so far away. So yeah, they have. And then 2 years later, the Canadians, not the Canadian government, but a Canadian contractor sent helicopters down there to put fires out. So they had helicopters down there on standby in the summer. They still do sometimes, and they have water buckets on them, and they dump water on these fires. So you're right. I mean, they really have adopted kind of this idea of quote, Western fire management. And why? Why did they do this? And I've talked to them about this over the years, and they just say that things like, well, we want to be like other societies that manage fire in some technological fashion, right? We don't want to be thought of as inferior, or that's probably the wrong word, but they just feel like they just got to follow what others do, right? So this is a real problem. Another thing about the martyr, which is a challenge, is the hierarchy. There's a national park. There's also a state fire agency. There's a Sierra San Pedro Ma observatory, which is run by UNAM, which is the preeminent university of Mexico in Mexico City. And there's all this kind of jockeying about who's got jurisdiction, who doesn't. And it makes it more difficult, frankly, to actually kind of come up with an idea of what you might do to achieve. My observation is the University UNAM in Mexico City's got a lot of weight. Okay, they have a lot of influence because of the observatory and essentially their standing in science. So yes, I think this idea of more and more suppression, helicopters, aircraft, equipment is all happening in the Martyr, and it's happening in parallel with more and more evidence of real change. I think when they saw the fuels data that I showed you a moment ago, they said, oh my God, it really is evidence something's changing, right? And they also saw the fire history data. Many of them had no idea that fire was so frequent up there for so long. I think both of those things, to someone that really isn't studying fire ecology or forest ecosystems, blew them away. So we will follow up with more conversation with them as they want. One thing is interesting too is they're nervous about us. I'm not talking about just in general, but they just, Americans coming across the border, and I've always been very humble down there. We've actually tried to get some managers of fire from Spain to come. They've actually are very interested in Spanish fire managers. Mark Castano, a friend of mine that's worked in Spain for many years, Catalonia, other areas. So, we've tried to maybe even get some Spanish folks down there to talk about prescribed burning. And I think that might crack an egg a little bit. But we still continue to do so, but we haven't been able to probably cover it up. And of course, I can't speak for the Mexican government or Mexican folks at all. It's their country, right? So, but we are trying to provide influences of just our data and trying to speak to them about the problems in the future.
Thank you. All right, we have another question here. Did you see a correlation between aspect and stand patchiness when thinking about trees
Mm.
per acre and basal area?
We haven't seen that, and that's an interesting one. You would think, I think in some ways you got an idea there. I think, some of those areas that are much steeper slope, much more southern aspect, just when you walk around anecdotally, you do seem that it's a drier site, and you probably do have changes in stand density index. It turns out that paper that we originally wrote on the wildfire impacts at Stevens et al. 2008, Ecology and Society, we actually made a mistake in that paper and we had to publish an erratum. We basically did a bonehead move of converting US units to metric units. I went the wrong way. I'm fully responsible for that thing. And the erratum basically showed correctly that the basal area and the stand density of the wildfire area is actually quite a bit lower than it is in that 49 plot grid that I told you about where the fuel loads have increased, which is actually a little bit more flatter ground, probably better soil development. So I do think there are subtle changes out there in that stand density and kind of competitive environment that could be explored. That would be interesting to look on. I think some folks have wondered about LiDAR down here. As far as I know, never been flown. Doesn't mean that it hasn't, but I've not really been part of it. Rich Minnick for many years, UC Riverside, did a lot of work down here. He was the reason that I started working in the March here. Rich Minnick, his papers always just got me intrigued. So Rich has done a lot of work on photography, repeat aerial photography, but I think there could be more to be done down there at larger spatial scales.
Thank you. All right, so we have another question here. Wondering if you can say more about whether climate change might be interacting with forest structure and fire regime in the system.
Yeah.
And if prescribed fire is reintroduced into the system, might we expect different outcomes than those in the historical burning record if the climate is different, aka warmer, drier?
No, another really good question. We know we had one paper that I actually I took out a figure, probably shouldn't have, and it actually would have addressed exactly your question. Because what we did is we did kind of a counterfactual analysis. So we tried to do an analysis to look at kind of the impacts of both the recent fire suppression that's happened down there, right? That's in the fire history record, and also climate change impacts. So Zach Steele, a former postdoc, now he works for the Rocky Mountain Research Station in Fort Collins, did a really interesting analysis where we tried to look at if the fire regime had not stopped. It stopped around, maybe you saw that picture, it stopped really. The last large fires in that country were like in the 60s. And then we had a few fires in the 80s, but they were tiny. They were probably suppressed. I don't know, but they were suppressed. Even in the years we were down there, in those several kilometer grids we worked in, we saw them put out fires. They are lightning strike on a snag, out, put it out. One fire got about 5 acres in size, cut a line around it. So we've actually witnessed it. We've seen it. So if you assume that the fire continued up through, say, 2022 or something like that, we actually saw a significant slight increase in regeneration that actually was modeled in this system if we compared the current condition with slightly more regeneration, seedlings and saplings, versus what it could have been if the fire regime actually continued. Just a few seedling saplings more today. But we also saw from a climate change signal from Zach's work that this is even a bigger impact, that the expected regeneration of the martyr is decreasing because of climate change impacts. And this is all in this paper that Zach Steele published and has kind of information. So I think we see both slight increase in regeneration from fire suppression and then also a little larger impact of climate change reducing regeneration. So I think what you're probably getting at potentially is this stable? Are we looking probably a change? I think we are looking at some change that's going to happen here. And we're trying to understand white fir mortality down here is high, especially large trees. Got a lot of true mistletoe down here, a lot of true mistletoe on the white fir. You see that all over Southern California. I don't see it very much in the Sierra Nevada, but the true mistletoe is a plant or fungi, not a fungi, it's a plant that is actually in these forests may be predisposing them to mortality from scolitis and fern graver. So we're wondering if we're seeing a shift in species composition down here from climate change. And this is something to continue to work with. One thing I would say, if you could just let fire work, right? If you could let fire work and continue to change that structure, interact with the climate, of course, I think in some ways you're probably going to do the best you can. Just let that thing continue to burn in some capacity. Let that selection happen. Let those mortality patterns exhibit. Maybe they're slightly higher, but when you look at the martyr today, even IROM's work, showing that the maximum high severity patch is 11 hectares, and most of them are sub 1 hectare, right? So this is a place that even today, with conditions slightly higher hazard, slightly more difficult climate from a warming standpoint, I still think could hum. I think it's still going to show the incredible ability of a top-down, versus bottom-up resilience. There's a lot of bottom-up influence in the March here with forest structure fuels and the ability of that to moderate fire behavior mortality. And we argue in the papers that it's the dominant process. The bottom up is really having the impact. And climate change is having an impact, but it's relatively subtle.
Thank you. All right, we have another question. Would you or could you mimic these conditions in some of the drier stands of the Sierra?
Yeah.
And would you need harvesting to achieve this rather than just prescribed fire?
No, that's a good one. And I think you absolutely could. You absolutely could do that. And I think this is something that really would be interesting to try. And I know managers, I've talked to a few of them over the years, are interested in this, but a couple things about it. The average canopy cover down there, we're talking about the 2D canopy cover, right, is just under 30%. Under 30%. There's some places 50%, 55%, some places 15, 20. The whole idea of average canopy cover also applies to this metric as well. We've got a couple of papers that show that the average canopy cover is relatively rare and you have a little more variation, right? So there's no doubt you could create conditions like this. And I've wondered about that. A lot of times I'm on 395 driving through the Inyo. A lot of the Inyo, of course, is cut, and then a lot of it's about 100-year-old Jeffrey pine today. A lot of it's very homogeneous looking to me, in terms of the stand density and kind of the spatial heterogeneity. Some of the old trees are gone because they were cut. But I think you could go into that country and you could do a silvicultural prescription to create something a little like the martyr. Okay. I think you could do it for sure. And you're right. I don't think you could do it with fire alone. These trees have just gotten to a point where they're relatively difficult to kill by fire, unless it's the worst fire. And we don't want to do that, of course, but prescribed fire, I think you can't really kill trees more than maybe 20 inches. 15 inches, 20 inches. So you could go in there and do silviculture and actually work on it and actually begin to create the conditions that we see in the march here. I think that would be a really interesting thing. I've actually talked to some of our forest managers at Blodgett Forest, which is more productive. Okay, Blodgett, you probably know, in Georgetown. And the forest practice rules actually prohibit creating a forest stand structure similar to the martyr on Site 1 land. You could maybe do it in Site 2 or 3. So it's interesting even to think that if you wanted to do this in some areas, the forest practice rules of California, these are state rules, would not even allow you to get down to the basal area and densities that you actually see in the martyr today. I think there's been some reform in that, and some people have looked into that somewhat. But I think trying to create some conditions that span some of these different structures, like the densities and the composition we see in the martyr in California, is a great idea. I think it's a great idea just to learn from it and understand what resilient systems might be. It's not to say that the martyr is the only condition. There's no way that's the case, but it's one of them. There's no doubt it's one of them. So I think that would be really interesting and cool to try to do that from a silvicultural perspective.
Thank you. All right, next question. Does the martyr require burning levels from the time of indigenous burning? Or are burning levels after the removal of indigenous burning, but before fire suppression, sufficient to maintain forest health and resilience?
Man, that's a tough question. It's a good one. I wondered the same thing. I wondered the same thing. You saw the patchiness of that fire history record pre-1800, right? And you wonder, what did that do? I would say there's no doubt it created even more isolation of regen, probably created more isolation of patches of regeneration that didn't have much litter. You burn those every few years, every 4 or 5 years, you probably going to have very low intensity or actually no burning at all. You look over to that post 1800 fire history and you see a lot of synchrony in those fires, right? So you got a lot of synchrony. That's got to be slightly higher intensity. That's the ability of fire to move at a longer interval, right? Longer interval between fires. So you're probably getting slightly higher intensity fire, and maybe potentially killing more of the regen. Maybe, that's an interesting question. Is it more, enough litter now that you're getting a lot more kind of continuous burning? In the 2003 wildfire, we actually tried to estimate how much of the area burned versus how much didn't burn. And it's in that paper. And son of a gun, my memory's not going to do me very good, but I think it was on the order maybe 65% of the ground burned, about 30, 40% of it didn't burn at all. Even after really a long period of fire exclusion, easily 40, 50 years, and still had that patchiness. And when we first got to the Martyr in 1998, there were three indigenous communities there: the Kiowa, the Papia, and the last tribe. Unfortunately, I can't remember. It's the one that actually comes from the Gulf of California, on the east side. So they all were there, and one of the tribes was still there, still living there in the late 90s until one of their elders finally passed away, and then Ernesto finally said that they decided to move off the mountain. And Ernesto, through all his time, tried to speak to them. He actually tried to get them employed at the national park to actually be stewards of the park and actually be employed. He thought that would be one way maybe to maintain kind of an indigenous presence. And Ernesto worked on that for a number of years, even with the United Nations, and he was unsuccessful. So, so I really wonder about what you're getting to, this patchiness of the indigenous burning pre-1800 versus not today. Is there a ramification? My guess is yes, but we have not been able to figure out how to go after that question. But I'd be really interested to know more about that, and that's an interesting way to think about that system.
All right, well, this may tie into it, but if you had unlimited resources, what would you want to add to this long-term study?
What was the last part of the question? Sorry.
What would you want to add to this long-term study if you had
Oh,
unlimited resources?
wow, that's a good one. That's a good one. That's a good one. You know, um, I've wondered a little bit more about the forest to the south. Those are lower elevation. So the lowest plateau to the south is 6,000 feet. And that's pretty low for a forest in this part of the world, right? So I think there's no doubt, my guess is climate change impacts are impacting those forests even more. What's going on with the regeneration down there? What's going on maybe with mortality patterns, things of that nature. Be really interesting to know more about kind of the more xeric forest in the Martyr. Not to say that they're really mesic at all, but the place we've been working is definitely the most mesic. It's got the most snow. It's got the most precip, I would imagine. So I think that working in maybe some of these other areas of dry forest that are further south, that means backpacking. You got to backpack. And you actually have to really know what you're going down there to find reliable water sources. They're there, but it's something I've only backpacked on that site once. It was pretty amazing. Um, but there's others, and you can actually rent and get mule trains and get folks, cowboys, to help you go places and stuff like that if it's all available down there. So I'd be really interested in more about maybe some of the dry sites. I'm still very interested too in the understory down there. And the understory is a hard one, right? Because a few years when you have El Nino, you get this incredible flush of understory species down there. I've seen it. And of course, then under the droughtier times, I hate to say, but the cattle come in and really graze it so severely. So I wonder more about the understory and what its capacity is, what its resilience is. Has it been impacted more by kind of the long-term grazing over 200 years? So I think that the understory would be another place that would be quite interesting. And then another thing would be maybe just how are trees accessing water down there? I've seen work people have looked at isotopes. Is it deep water, surface water, different types of water? It'd be interesting to know kind of the partitioning of the water reserve down there, especially during drought. How are those trees persisting under a 4-year drought? Ernesto had a temporary weather station during the drought down there. One year they got 5 inches total precip, 5 inches. Can you imagine 5 inches, how bone dry that was? I remember walking around in dust. So how are those trees accessing that water, and how are they able to deal with things like bark beetle mortality, resist it? So there's certainly more things to do down there. And also someday maybe LIDAR. Somebody could do some work on maybe some more spatial patterns at larger scale. Maybe the burned areas, but that we don't have a lot of burned areas to go after, unfortunately. But I think you could do some more work on just the spatial patterns of the trees and clumps down there with a LiDAR analysis, which would be kind of interesting.
Thank you. All right, I think we have maybe time for one more question. We'll see how quickly we go. So since the US tends to look at average and median characteristics, is there any value in looking at the average and median variations in characteristics that are most characteristic of robust and survivable forests?
I think there is. I think there really is. I think this is something that we could deliberately do, right? The rule of thumb in the Martyr, and this is a rule of thumb, is about 60, 2/3 of the area is below average. That's just a rule of thumb, okay? Surface fuel load, basal area, tree density, snag density. So you get about 2/3, 60% of that place is below. And it's quite a bit of below. It's not like just a standard deviation or something. I mean, it's a lot lower, maybe half, maybe less, right? But that means also you got 1/3 that's higher. You got 1/3 of the system is higher basal area, fuel load, snag density. So of course that is a very rough cut, but I wonder if we could partition our standards and guides to do something like that, to actually say, oh, maybe we want 120 square feet per acre. Oh, by the way, maybe we'll do that by having 1/3 of our stands maybe at 150 and 2/3 of them, let's say, from 30 to 60. I think you could do that, right? You could do that in some creative way because the Martyr, one thing it screams at us that the idea of average characteristics everywhere is basically not found. It's not there. You can't find it. So I think it's one reason why, again, it's so resilient because of that discontinuity, that ability to deal with things like insects and fire and drought. So I think this idea of maybe 2/3, 1/3 distribution of a lot of these spatial characteristics that we're interested in, snag density, forest woody debris, would really be remarkable to try to figure out how to do that. I know the marking guides would be more complicated, right? The ability to communicate that to crews, but we've got GPS systems today. We've got technologies that could help with that, right? So I think it really is time for all standards and guides, at least in frequent fire forests, to actually want and desire more variation inside those things. That's a great question.
Thank you so much, Scott. So we have a ton more questions, and unfortunately, we're not going to be able to get to them all. But as we wrap up today's session, I just wanted to say thank you everyone for joining us. And of course, a special thanks to Professor Stevens for your fascinating presentation. I think we had a really engaged audience, so thank you everyone. We have our next session scheduled for February 11th, so next week at 10 a.m. when Sarah Clark and Jenna Archer are going to be discussing the realignment of federal environmental policies to recognize fire's role. So we'll drop a link in the chat for that right now, so you can check that out and register if you're interested. And then before we sign off, we will be sending out a webinar evaluation shortly. So please keep an eye out for that. And if you can fill that out, it really helps with our funding agencies. So thank you, everyone. And we look forward to seeing you at our future sessions. And thank
Thanks
you
for the
so much,
questions,
Scott.
everybody. That was some of the best questions I've had for the Martyr. And I just encourage you to go. If you want to go down there, just go. We'll go, we might go next year. A lot of times we bring people too. So, we try to bring folks down there. But if you're interested in that place, just set up yourself a little trip and head down, man. Just bring your camping gear. Nice people, nice place. So if you want to go look at it, it's certainly available.
All right. Thank you, everyone.
Bye-bye.